British Columbia's directed deepwater trap fishery for sablefish began in the late 1970s. Established by harvesters in 1987, the Canadian Sablefish Association works with the Department of Fisheries and Oceans to protect the long-term sustainability of the fishery. Both groups are committed to the care and management of the fishery, including stock assessment and research to improve understanding of both the resource and the marine ecosystem. The CSA has a long history of forward thinking about the need to protect the marine environment upon which its members depend for their livelihood. To this end, they have been working with Simon Fraser University and Nuco Research to develop a deepwater camera system to map seafloor habitat and investigate the effects of fishing gear on the bottom. The TrapCam system has a 1500 meter depth capability with a programmable activation depth. It can capture HD video or 5 megapixel images with an onboard 5000 lumen LED lighting system. Video and image recording is triggered by an internal timer or by trap motion. The motion sensor triggers the camera and lights while an onboard computer records acceleration, rotation, and compass heading with sufficient battery power for deployments of up to 5 days. The cameras can be mounted in existing trap gear with minimal effort. Traps equipped with cameras can be handled like standard fishing traps during setting. And during hauling. Until now, fisheries have been conducted without fully understanding the impacts gear may have on the seafloor, or even the specific types of habitat over which they take place. Our understanding of the organisms living in these habitats is also lacking, despite evidence of their importance in providing shelter and nursery habitat for fish species. The depths and uneven distributions of many of these species present serious challenges to researchers. Having individual traps with cameras provides the potential for high-quality habitat and species data over a huge spatial area. Camera-equipped traps allow mapping of habitat types, such as this muddy bottom with shrimp and brittle stars. These rocky volcanic outcroppings dusted with mud and supporting brittle stars, shrimp, and sponges, or this complex bedrock habitat with brittle stars and feather stars living on it. Trap movements during gear retrieval can be matched to instrument data. This graph shows trap movement over the course of a single deployment. Red, green, and blue lines show X, Y, and Z components of the trap acceleration. This area shows the rolling motion captured in the video. The actual impact of the gear on the bottom can then be estimated. Cameras can also collect useful data on abundance of commercial species like these thorny heads. Or rarely filmed species such as the Pacific flatnose. Or these Pacific grenadier. Including observations of behaviors such as feeding. These fish hover, head down, and pick off prey items from the bottom. These camera systems have already yielded valuable data on fishery impact, habitat distribution, and species abundance. More vessels and harvesters using such a system could provide truly revolutionary amounts of data. Funding for the development of the TrapCam and initial data analysis was provided by the Canadian Sablefish Association. TrapCams were designed and built by Nuco Research in conjunction with Simon Fraser University's School of Resource and Environmental Management and with the support of the Department of Fisheries and Oceans.